This is a hypothesis test about mu, the population mean. We are going to do the p-value method. The mean age in senators in the 109th Congress was 60.35 years. A random sample of 40 senators from various state senates had an average of 55.4 years. The population standard deviation was known to be 6.5. At an alpha of 0.5, is there sufficient evidence to state that the state senators are on average younger than the senators that are in Congress? We notice that the population standard deviation is known, and so we will be using the z-table because the population standard deviation is known. The significance level we'll be testing this at is 0.05. And then they want to know, are the state senators younger than the senators that are in Congress? So that'll help us set up our hypotheses. The null hypothesis always has the equal sign in it. And then they are claiming that the state senators are younger than this, are less than this. So we're going to put the claim with the less than sign, the younger sign. Then the next step will be to calculate our test value. We're calculating a z using this formula. The mean that they're using from their state sample was 55.4. Then you subtract away the hypothesized mean, 60.35. It is over the population standard deviation and then the square root of the sample size. So the denominator is 6.5 over the square root of 40. In our calculator, I'm rounding, negative 4.82. To find the p-value, what we do is we look this up, the test value, on our z-table. So we'll be going to our z-table. We'll be looking up negative 4.82, and we'd like to find the area in the tail to the left of that. Now, this is interesting because there is no 4.82 on this table. If you look, the highest this goes is negative 3.49, but then when you look at the bottom, it says for z values that are less than negative 3.49, use an area of 0.0001. So that's what we'll have to do because our test value is so small. So we'll be using an area of 0.0001, even though we're not on the table. Now, that is our p-value. We don't double on this one because this is just a left-tailed test. You just take the area in the left tail. And again, we know this is left-tailed because of the direction that the alternative is pointing. So our p-value is 0.0001. And then on step 4, you make this decision by comparing your p-value to the alpha value. So we're comparing this number to the alpha was 0.05. I got that from up above here. And this part of the problem right back here, 0.05. When the p-value is smaller than the alpha, you reject the null hypothesis. So we are going to reject the null hypothesis. Sorry, my handwriting went a little nuts there. We're rejecting the null hypothesis because the p-value was smaller than the alpha. And then when you look up here, we're actually rejecting the null. We're rejecting that one. And so we're saying the alternative is true, and the alternative has the claim associated with it. So we are supporting the claim. We're rejecting the null, which means the alternative is true, and the alternative has the claim with it, so we're actually supporting the claim. Go back down here. There is enough evidence to actually support the claim that state senators are younger than the senators in Congress.